1. Integration by parts. Here's a visual picture of the integration by parts formula. Let's see how we can derive it. We start with two functions, u and v. They are functions of x. According to the product rule, when you differentiate u times v, you get u prime v plus uv prime. Now, when we integrate both sides of the equation, we got this. This side, we have an integral of u prime v plus the integral of u v prime. Remember, indefinite integral represent families of functions, so the left side and the right side of this equation represent the same family of functions. According to the fundamental theme of calculus, when we differentiate a function with respect to x and then later on integrate that with respect to x, what do you end up with? Let me know what do you end up with on the left side of the equation.
uv.
uv, yeah. Differentiate the product of uv and then later on integrate that. Differentiation and integration are reverse processes, so they undo each other. So on the left side, you end up with uv. On the other side, what do you get? Notice that u here is a function of x. So u prime is the derivative u with respect to x, which is du dx. So the differential du is equal to u prime dx. So u prime dx over here is du. Similarly, v prime dx over here is dv. So this becomes the integral of v du adding the integral of u dv. So v prime dx is this du and your v over here. V prime dx is this dv and you have u over here. So uv is equal to the integral of v du adding the integral of u dv. Now we're going to isolate this integral u dv. So the integral of u dv is equal to uv minus the integral of v du. So we have just discovered the integration by part formula. Notice in this formula, u and v kind of like switching places. Now, how do we use it? Let's do some examples. In the first example, this integral, we don't have a direct formula to find its antiderivatives. So we consider integration by parts. So let's decide which function to be u. Which one would you like?
Sine of x.
That might be, okay. So you can try, okay. So it turned out that it's actually, I'm going to teach you guys a trick, a pattern to choose.
U equals x sine, du equals sine of x.
Yes. Yeah, I'm going to teach you a trick later. I'm going to teach you a trick so you know all the secret, which one to choose to be u. So I'm going to let u to be x, and then dv over here is sine x dx over here. So this is u, and then dv will be this. So u is equal to x. Du will be dx. dv is sine x dx. We're going to find v by integrating sine x. In other words, what's the most general antiderivative of sine x?
Negative cosine x.
You got it. Negative cosine x. We're supposed to add a constant at the end, plus c. However, for simplicity, I'm going to choose this constant c to be 0. I'm going to let you think about this at home. Why can we choose this c here to be 0? If you choose c to be other constant, would the result to be the same? And you can prove it. So I'm going to choose this constant c here to be 0. So v is equal to negative cosine x. That's why the integration by part formula one more time. uv minus integral v du. Over here, u is equal to x. V is negative cosine x. V is negative cosine x. And du is dx. Now we're going to simplify it. Take a look at this integral over here. The integral cosine x dx is simpler than the one that we start with. So we are heading in the right direction. And we know the antiderivative of cosine x. What's the antiderivative of cosine x?
Sin x.
Yeah, sin x. So antiderivative cosine x is sin x. And then this one we just copy. And don't forget at the end, we need to add a constant. Because this is an indefinite integral, okay? So don't forget to press a constant at the end, okay? All right, and we're done. Now, how can I check if this is the right answer here? You can differentiate this and see if we end up with this function, x times sin x, okay? Question?
Teacher, so at the beginning we choose u and the dv. So it's like the u substitution, but differently.
Okay, don't confuse this with u substitution, okay? U substitution, you choose a u, and then you try to have the du match with some function in that integral. But this one here is actually you choose u, you also choose the dv here. And then for u, you differentiate. For dv, you integrate that, and you find the v here. And then you get uv minus the integral v du. So it's two different methods. The u substitution method, and this is the integration by part method, two different methods. Okay, good. So the u sub method, you just stick with it. You just choose some function in the integral to be u, and then find the du. But this one here, integration by part over here, you separate that into two parts. One part is a u, the other one is the dv. And you follow this process here. Okay, let's practice a little bit more. Okay, so yeah. Now I have a couple week mark to make. I'm going to give you some secret tip how to choose a U. Okay, the first week mark here. The goal of this integration by part is try to get a simpler integral than the one that you start with. Okay, so when you use integration by part, the example we did over here. This integral is simpler than this integral, than the one that you start with. So you're going down the right path, okay? Another, number 2, we mark here. When you choose u over here for this integration by part, you choose u so that u prime is simpler. For example, this function that we integrate, we choose u to be x. U prime will be x prime, which is equal to 1. 1 is simpler than x. This integral over here, we're going to let u to be ln of x. So u prime is the derivative of ln of x, which is 1 over x. 1 over x is simpler than ln of x. Okay, the number 3 trick. So this is a secret one. It's not in our book, okay? So this is the integration by part formula. And you select u in this order. The order is L-I-A-T-E. L-I-A-T-E. You go down this order, okay? Now, the way that you can remember here is L-I is actually a very popular Chinese last name, Li. A-T-E is actually the past tense of eat. And back in China in the old time when we meet each other, the first thing we greet is, have you eaten yet? So Yes, 你吃了吗? Okay, so you can try to remember that. So D8 is this order. Okay, so what does this L here stand for? Take a guess. L here stands for log function. So if you have a log function, you let U2 be that log function. So Ln or log. Okay. The I here stands for inverse trig. So if you don't have a log function and you have inverse trig function, you let U2 be inverse trig function. So inverse sine, inverse cosine, inverse tangent, etc. So go down this. The A here stands for algebraic. Okay. So give you some example of an algebraic function. It's going to be, say, x.
X squared.
X squared. Yeah, you got it. Okay. And then square root of x, square root of x plus 1, etc. Those are algebraic function. The T here stands for trig function, trigonometry function. Okay. For example, sine, cosine, tangent, etc. Guess what the last one here E stands for?
Exponential?
You got it. Exponential function. So it could be e to the x, 2 to the x, etc. So it go down this order. Okay. So you choose U in this order. Liate. First this, and then this, and this, and this. Okay. Okay, let's use this in our next example. So in this example, we're going to try to use integration by part. Okay, let's take a look at the function. X squared is what kind of function? What type of function?
Algebraic?
Algebraic. Okay. E to the x is exponential function. So which one you want? Okay, remember Liate. Right? Which one you want to let U to be?
X squared?
Yes. So we're going to let U to be x squared.
Did you come up with this yourself, Professor?
No.
Oh, I was about to say that's so.
Yeah, I saw it somewhere. Okay. Okay, so A is before E, so we're going to let U to be x squared. So we use by part. So that will be equal to uv minus integral v du. And we let U to be x squared. And then we let dv to be e to the x dx. Okay, so what is du?
2x?
It's 2x. Almost 2x what?
Dx.
The differential, dx. Okay. So that's the differential. So du is 2x dx. Okay. All right. So dv is e to the x dx. Okay. So what does v equal to? Let's find antiderivative e to the x, which is what?
Yes.
E to the x, right? So e to the x. We choose the one with the constant to be 0 at the end. Okay. All right. So now we found the u and v and du dv. Now we're going to put it into the formula. So this will be x squared e to the x. Let's simplify this a little bit. Okay. So there e to the x. Take out this constant multiple 2. And then x dx. Take a look at this integral that we end up here. Okay, the function that we integrate is x to the first power times e to the x. The one we start with is x to the second power times e to the x. So this one here is simpler, right? So we're at the right track. Okay, so over here we use by part once. Then we got this. What do you think? How do we take care of this then?
U substitution.
Mm.
No, one more time by parts.
By part one more time. Because see, what happened over here is you use by part once, the exponent on this x here go down by 1 now, right? And then if we do it one more time, then you will have x to the 0 power, which is
1. Okay.
which is 1. So we're going to use by part one more time. Okay, let's do it over here on the side.
Wait,
So
you can keep doing that?
yes, you can keep doing it. So x to some power. So I can tell you a trick, the pattern. X to some power times e to the x. When you integrate this type of function, you use integration by part. And every time you do it by part once, then this exponent is going to go down. Okay, it's going to go down by 1. Okay. Okay, so over here, I'm going to choose u to be x because it's algebraic. So, and then this to be dv. Yes.
I'm sorry. Is there a way to integrate by parts many times all at once, or do you have to do it again each time?
Yeah,
That was what I was trying to ask.
There is a formula. There's a formula. So, for example, there's an x to the 5th power. Okay, so suppose over here is x to the 5th power e to the x, and you integrate that. There's a formula. You can go directly.
Oh, okay.
Yeah, there's a formula. It's very complicated, but the way they got the formula is actually they do the integration by part again and again to get the formula.
Okay, I see.
Okay, you got it. Okay, okay. So over here, let's just do it by hand. Okay, so integration by part over here one more time. So I get u to be x, dv to be e to the x dx. So du over here will be what? Du will be equal to
Yes.
dx. Yes, dx. Okay, because u equal to x, du is dx. And then what about v? What does v equal to?
E to x.
Dx.
Yes, very good. So this is dv. So integrate e to the x, you get e to the x itself. So that's e to the x. Okay. So this integral x ex dx. So that's equal to uv minus integral v du. So that's equal to, okay, x e to the x minus integral e to the x dx. Right? See, this is this, and this is this. Now you see that it's actually simpler now. Do you see here? Now this is you don't. So now you have the integral e to the x now. Okay, it's simpler than this. Now we have this x e to the x here minus this will be what? E to the x. And you're supposed to put a plus c right there. Okay. Then this is going to be this whole thing over here. Actually, is going to match with this integral over here. This integral over here is going to become this. Okay, so you just copy right here. Okay, so let's write down. So that will be x squared e to the x minus 2 times this result over here. Okay, and now let's distribute the -2 inside the parenthesis. So that is equal to x squared e to the x minus 2x e to the x plus 2 e to the x. and then plus a constant, let's call the constant d. Okay, the d over here is, what is this d? The d here is equal to
C.
negative 2 times this constant c. Okay, question? So this one you use integration by part, okay, twice. Okay, now if you go down over here, you take a look. So we use integration by part twice, 2 times. So if it's like x to the 5th power e to the x, when you integrate this function, we're going to use integration by part how many times?
5
times.
5 times. I'm not going to ask you to do that. Okay.
Teacher,
Yes?
why is d equal to minus 2c?
Oh, you see this one over here? This is negative 2. Okay, let's fill this in. X.
Oh, you distribute.
X minus e to the.
Okay. No, I get it. Okay.
I see. So yeah, now you distribute over here. That's equal negative c.
Okay, thank you.
Okay. Now I'm going to tell you a pattern. So the function that you integrate with is called integrand. Okay. When the integrand here is in one of this form, x to some power times e to x, or times ln of x, or times some trig or inverse trig function, you will consider using integration by part. Okay? Yeah. So those are called transcendental function. Okay, so you will consider using integration by part. Okay, and sometimes you might want to use substitution first and then do integration by part. Okay, so you have to combine 2 methods. So the first one you do substitution, and then later on you use the by part method. So you use 2 methods in one exercise. Okay, so
Substitution? You mean the use substitution?
Yeah, substitution, use substitution.
Okay.
Yeah. Okay. So over here, this function that you integrate with, you kind of wish this square root of x here to be a single variable, right? So I'm going to do the substitution first. And because integration by part has a u, so I'm going to choose w for this, okay? So I want the w over here to be, so I'm going to do a w sub, okay, substitution. So I'm going to let w to be square root of x. What, which is x to the 1/2 power. So what is dw? There used to be a character in cartoon called dw. Okay. So random. So dw is equal to what? So 1/2, differentiate this, x to the what power? X to the
negative 1 over
negative
1/2.
Yes, you got it, negative 1/2. X1, and then don't forget dx over here, right? Now this dx over here is going to be equal to, if you solve for dx over here, if you isolate the dx here, that will be equal to dw times x to the 1/2 power, right? Okay, so you will get 2 times x to the 1/2 power dw. Okay, now remember, when we do the substitution, here, this dx here, I want it to be all in terms of w. I still have the x to the 1/2 power here. I still have the x here. So I want to relate this to w. Now, we know that w is x to the 1/2 power. So this is just w. So dx is 2w dw. Okay, so it has to be all in terms of w. Okay, so after we did the w sub, this become e to the w, and dx become 2w dw. Okay, so all in terms of w. Okay, you don't want to mix them. You don't want to mix the x with the w. Okay. Now after this, you can take out this 2 in front, and now you have this w e to the w dw integral. Take a look at this form here. What kind of method that you want to use to find the integral?
So by parts?
Yeah, by part. Because this is in the form w to some power times e to the w, okay? So we want to use by part. So this variable to some power times the transcendental function e to w. So use by part, okay? Well, we already did this, okay, by parts. So don't forget the s, okay? All right, so our last example, we did this, right? Do you guys remember? So because it's in this form, w to some power times e to w, this function that we integrate with, so we're going to use by part. So our last example, we already did this. So when we integrate x e to the x, we get this. Now this one here, we just need to replace this x over here by w, okay? So we got a 2. So we place this x here by w, and then we got this result over here. Now remember, we want to return back to x, okay? And then I can distribute the 2 inside. So I got 2 questions.
Should we learn the general formula for this particular case, or maybe it makes it faster, like the integral of x to, yeah, should we learn that, or
You don't need to memorize it. You don't need to. Okay, any other question? All right, so that's integration by part. Okay. Okay, now this one here, the function that we integrate with is e to the x sin x. So want to use integration by part. So e to the x over here is what kind of function? Exponential function, right? Sin x here is the what? Trig function. So what I'm going to let u to be?
Sin x.
Sin x. So I'm going to let u here to be equal to sin x. And then dv will be the rest here. So dv will be equal to e to the x dx will be the remaining part right here. Remember for integration by part, right? What was the order? So we're going to choose u to be, so we go down the order, L-I-A-T-E, right? So which one, you already answered that. So we want u to be this trig, okay? Because trig function before exponential function. So you want this u to be this trig function, which is sin x over here first. Okay, that's why we choose u to be sin x. Okay. Okay. Now, if I have u to be sin x, dv to be e to the x dx, let's find out the du and v. What will be du? Du here will be what?
Cosine x dx.
Okay, let me write down. U is sin x, and then dv is e to the x dx. So du here will be cosine x dx. So just differentiate. And v will be integrate this. So that will be e to the x, right? Now, according to the integration by part formula, so this will be uv minus integral v du. Now we just substitute. U is sin x. V is dx, v is e to the x minus integral v here is e to the x, du is cosine x dx. Okay. Now take a look here. The function that the integral that we start with, this is the function that we integrate is e to the x sin x. Now when I do integration by part over here once, that somehow I got e to the x cosine x. So the sin x alternate into cosine x. Do you see a pattern? Because the derivative of sine and cosine alternate, right? Okay. So what happens if I do integration by part here one more time? Do you think I'm going to end up with e to the x sin x inside the integral? That's probably the case, right? Okay, let's try out, okay? So I'm going to do integration by part here one more time. Someone said, why do you want to go back? Well, think about this. If I end up with something the same as this, I'm going to have an equation of this integral. And then I can solve that equation for that integral here, right? So let's do integration by part here one more time, okay? For this integral. So this here is exponential. This is trig function. So we're going to let u to be what?
Sine. Cosine x.
Yeah, so for this part over here, we're going to let u to be cosine x, and then dv to be e to the x dx. Then du will be negative sine x dx, and v is going to be what? Antiderivative e to x over here will be, are you guys with me?
E to the x.
E to the x. Yeah, e to the x. Okay, good. So we just do it one more time. So u to be cosine x, dv to be e to the x dx. Then du, the derivative cosine x is negative sine x. So you have this. And find antiderivative e to the x, we get e to the x. Okay, right here. Okay. So we do it one more time. Then using integration by part one more time, this one here actually become, what does it become? So it become e to the x, and then times cosine x minus the integral of v du. So it's e to the x, du is negative sine x dx. Okay, so we end up with this. Okay, now we want to simplify this. So minus negative times negative is positive. Okay, so that should become a plus. Okay, so what do we end up here? So this, so let's write it down. Okay, that is e to the x sine x, then minus e to the x cosine x plus integral e to the x sine x dx. Now you think that we're going back in the circle. It's like, look, I get back e to the integral e to the x sine x right here, right? Now, actually, this is going to be helpful because the integral that we tried to find in the beginning was the integral e to the x sine x. You see what happened over here?
I think that should be the negative, the minus, not the plus.
Oh, it's the yeah. You got it. Thank you for this. Now, because this one here, it is a minus, this negative times negative, so it's a minus. Yeah, you got it. So let me erase it. Yeah. So this one over here, thank you for pointing this out. So it is minus. So let me make a comment. This is a minus here. So this is a minus. Okay. Minus. So this, I'll go back a little bit. So this result here will be equal to e to the x sine x minus e to the x cosine x minus negative times negative here become positive. So minus this integral e to the x sine x. Okay. Now this one here, this integral is exactly the integral that we're trying to find. Okay, in the beginning. So the integral that we're trying to find in the beginning is equal to this. We can regard this integral here as a kind of like a variable that we're trying to solve, right?
So it's like an infinite loop?
Oh, it's not infinite loop. It's actually
two times.
Yeah, remember this integral is the one that we're trying to find, and we got this. Think about it as a variable. Let's call this I, okay? The integral I. Integral start with I, so I. So I can add this to both sides, so I get 2I, right? 2 of this integral. That's equal to e to the x sine x minus e to the x cosine x. You can take out the common factor e to the x. also, right? So the integral that we're looking for, now we can divide both sides by 2 to find the integral that we're looking for. So what is that integral? E to the x times sin x minus cosine x, and then divide by 2, and that's the result. Okay, so that's the answer over here.
Is there any like plus C's or D's or in this one?
Oh, you're right. I forgot plus C. Extra credit. Okay. Yes, plus extra, plus a C. Don't forget, this is a indefinite integral, plus C.
So the C would be C over 2 or just C?
Just put plus C because C is arbitrary. C is an arbitrary constant. When you divide by 2, you just get another arbitrary constant. Just put C.
Okay.
So the answer here is this. Yeah. Don't forget that adding a constant C at the end. Are you guys good? Okay. Now, if you take a look down here, I actually have a remark for you guys. Okay. So sometimes when you integrate e to the x times sin x or times cosine x, after by part twice, okay, we got an integral that is the same as the one that we start with. Then we can solve for that integral. Just like what we have done here. We can solve for that integral. Okay, got it? Question?
Yes, thank you.
Okay, good. Okay, now this integration by part over here, there's another way to write this formula. Okay, so if I let u to be f of x, v to be g of x, then du dx is f prime of x. Both of them represent the derivative of u with respect to x, right? So if you regard the du here as a differential, so that will be f prime of x times the differential dx. Similarly, dv is g prime of x times the differential dx. So this formula over here actually becomes this. The u here is f of x, dv is g prime x dx. Okay, u is f of x, v is g of x, u is g of x, du is f prime of x dx. So it's this formula. It's the same formula. Now, if I write it in this way, I can put down the upper and lower limit. So make this a formula for the definite integral. So if x here go from a to b, then this will be this go from a to x go from a to b, and here x go from a to b. So you put like this. You don't put a to b here because it's not v go from a to b. It is x go from a to b. So only when you put it in this form, you can put down from a to b, a to b, a to b like this. Okay. So this is the integration by part formula for definite integral. The upper and lower limit are specified. Those are called definite integral. Now let's try this one. Remember, this is called the inverse tangent function, the arctangent function. The graph of this is like this. Remember the dance move for the inverse tangent, kind of like a Tai Chi move, okay? Like this, okay? So tangent of power 2, tangent of power 4 is equal to 1. So inverse tangent of 1, that's equal to pi over 4. So that's a review for inverse tangent. Okay, just to refresh some of your, just refresh your memory. What's the derivative of inverse tangent? Anybody remember that?
1 over 1 plus x squared?
You got it. Okay, good job. Okay, 1 over 1 plus x squared. That's good. Okay. Now today, over here, we're trying to find the integral of inverse tangent. Over here, this definite integral here, x go from 0 to 1. You cannot use this formula. This is the derivative of the inverse tangent. This is the integral in inverse tangent. So it's not this formula. So to find this, we have to use integration by part. Okay. So I don't have a choice. I can only let u to be this. This is the only function. So I let u to be this. And then dv to be dx. Okay. All right. So remember we say that by parts, when we have x to some power times some transcendental function. Okay. For example, what kind of transcendental function, such as a trig function, okay, inward trig function, okay, like, or e to the x, okay. All of this we use by part, remember, right? We use by part, okay. So this one over here, you can think about this as x to the 0 power times this inverse trig function, inward tangent, okay. So we use by part, okay. So u to be tangent of x, du is dx. Okay, let me write down. So u equal to inverse tangent of x, dv is dx. So what is du? So what's du? Du, you just found the word here. Remember it here? You just said
1
that.
over 1 plus x squared
Yes.
dx.
Yes, you got it. 1 over 1 plus x squared dx. You got it. And then v here will be what? And what's integrated? What do you get? It's just x. Yes, you got it. Just x. So using integration by part formula, so this will be equal to uv minus integral of v du. So that will be uv. So that is x inward tangent of x minus integral v du. So x du here will be this dx. Now I think I better don't put this one here in because this is a definite integral. So here will go x here go from 0 to 1, 0 to 1. Now if I put it this one, I cannot put it 0 to 1 here because u is not going from 0 to 1. U is a function of x. So I think I will erase this. Okay, erase that part. Don't write that part. Okay, and you go straight to this. So we get this. So for definite integral. Okay. Now the first one over here, we will substitute 1 in it and substitute 0 in it. Okay. So you will get 1 times inward tangent of 1. What's inward tangent of 1? We just talked about that.
Pi over 4.
Pi over 4, right? So that is equal to pi over 4. Okay, this part here is x over 1 plus x squared dx. X go from 0 to 1. What kind of method to integrate this?
Substitution.
Substitution. Yes. How can you tell? You're looking at this, okay? So this one here, degree 2, and here is degree 1. Okay. If I let w to be this right here, if I let w to be this part right here, then dw. So what's dw?
2x dx.
Yeah, that's equal to 2x dx. And that is going to match with the x dx here. It's going to match with this, right? So you're going to use substitution method. Okay, so we do the w sub here. Okay. Okay, so now minus. So I do the substitution. So that is 1 over w. And the x dx here is going to be dw over 2. So I put dw, and then over 2, I will put the 1/2 over here, okay, over 2, because x dx here is dw over 2. So now let's think about what to put here as the upper and lower limit. I cannot put 0 to 1 because x go from 0 to 1. W is not, okay? W doesn't go from 0 to 1. So let's find out what here is. What the W here go from where to where. So when x equal to 0, substitute x to be 0. What does W here equal to?
1.
1.
equal 1. So the lower limit here will be 1. When x equal to 1, what does w here equal to?
2.
W equal to 2. So upper limit here will be 2. So remember the change upper and lower limit here for this after you do the substitution. Okay. Okay, that's good. Now this one here, this part is power 4 minus 1/2. Do you guys remember anti-duality of 1 over w with respect to w? Which function you
Is it
differentiate?
ln?
Yes, ln. You got it. Okay. ln of the absolute value of w. Now, it's important to put the absolute value there when the w value here will be negative. So it's important, okay? But in this case, it's okay not to have it because the w value here go from 1 to 2. They are positive, okay? So let's continue. So this is power 4 minus 1. Oh, don't forget. So don't forget this one over here. The w go from 1 to 2. Now, let's put this here. So this is power 4 minus 1/2. Now this is ln of 2, subtracting ln of 1. What's ln of 1?
0.
0. Yes, ln of 1 is 0. So the result will be power 4 minus 1/2 ln of 2. And that's it. Got it?
Is it plus C or?
Not plus C. Okay, not plus C over here. Because this
Nice
is
try.
nice try. Okay. So because this one here is a definite integral, the x you go from 0 to 1. The result here should be just a single number. Yeah. So if it doesn't have a 0 to 1, it's an indefinite integral. That's a family function that you plus C. Okay. Good question. Okay.
I was just wondering.
Wow, it's good that you can always back in your mindset. Should I put plus C? That's good. Okay. Okay, the last page here is a homework help for you to help you with your homework. Okay. So we call that the duality of secant of x. Do you remember the SST rule? The trick I told you? SST? The duality of secant is what?
Secant tan.
Secant times tangent. Yes, you got it. So then here you have secant x times tangent x, right? Now, what about anti-duality of secant x, integral of secant x? We actually did one example. Do you remember? If you remember, I give you $1.
Is it tangent squared?
Tangent square is no, it's not. Okay. Anyone? $1. Okay.
Tan?
No.
Oh,
Anti-duality this is also related to secant and tangent, but it's related in this way: ln of the absolute value of secant x plus tangent x. Yeah, I think we did one example. I don't remember either. Don't feel bad. Okay.
wait, that's
Don't forget plus C. Yes.
okay.
You can always watch out. Did she forget the plus C there? Okay.
Extra credit.
Yes, extra credit. Okay, keep an eye on that. Okay, I will offer extra credit if you catch any mistake that I made. Okay.
Oh, nice.
Okay. Keep your eye peeled.
Nice. Great way for us to participate.
Yes, yes, of course. Okay, so it's also related to secant x tangent x, but it's related in this way. So you can try to put them side by side and try to remember it. Okay. Okay, what about secant q? Secant q over here. This one over here, actually you have to use by part to do this, to find the result. So first separate this into two parts, secant x times secant square, okay? And then you're going to let u to be secant x. And then dv over here to be secant square x, okay? And then dx, okay? Now, when you use by part, then du over here is going to be what? Du is going to be secant x tangent x dx, right? Good. What about v? What's antidual to secant square?
Tangent x.
Tangent. Yes, you got it. Good job. Okay. So antidual to secant square is tangent, right? Tangent x. And then supposed to put plus c, but we're going to make this c to be 0 just to, because the result will be the same if you use other constant. Okay. Remember, I assigned you to think about that at home. Okay. So this one here, using the integration by part formula, so that will be uv minus integral of v du, right? Okay. So that will become u here is what's u? Secant x. Secant x. V is what? Tangent x. And then minus integral v here is tangent x. Okay. And then u here is what? U is secant x tangent x dx. Okay, so that was this. Okay. Now this part over here, you will. This is going to be secant x times tangent square x. Okay, now let's use the identity. Do you guys remember the identity? 1 plus tangent square x equal to what? Do you guys remember this trig identity?
Secant square?
Yes, secant square. Okay, good job. Okay, so use this identity. Okay, so we're going to replace this tangent square here by 1. This tangent square here by secant square minus 1. Secant square minus 1. Okay, replace by that. And then you're going to distribute. Okay, so we're going to distribute this secant x, okay, inside. And now let's see what happens. So that's going to become secant x, tangent x, minus, this is secant q, remember? Okay, okay, let's just do it step by step, minus secant x dx. That will become secant q x dx plus secant. Now people say it looks so much more complicated, right? But there's a point over here. You see what happened? Do you recognize this one? Is this the integral that we're looking for? Let's call that I. The integral that we're looking for is exactly this one over here that we have, right? So the integral we're looking for is equal to this minus that integral plus this integral. And we know this. The integral of secant x here is what? This one over here, it is ln of the absolute value of secant x plus tangent x, right? And then plus c, right? Okay. So we can solve for this integral, right? So we get 2 times this integral is equal to secant x tangent x plus ln of this secant x plus tangent x plus c. And now we can divide both sides by 2. Finally, we got the result. Okay. So this integral will be whatever you have over here. Okay. And then you divide by 2. And then divide by 2, which is equal to secant x. I might just write it down. Plus ln of this secant x plus tangent x, and then over 2. And then plus a constant d, where d is c over 2. Okay. Do you guys get it? Sorry, I went over so much today. C over 2. Okay, but we covered this. Okay. Now you're ready to do 7.1. Wow, there's a lot of information today.
Yeah.
Yes.
A lot.
I haven't had a lesson like that in a minute. Not gonna lie.
I know. Okay, I'm going to stop sharing. Okay, welcome. Thank you guys for coming.
It's au revoir.
She's getting there.
Oh, wow. Okay, I practice after the comeback. Oh, wow. Oh, wow. Okay, I get it. Okay, French afterward, okay?
Good.
Okay, all right, bye everyone. So today's theme is friends. So I have this lavender field. So France is famous for its lavender field. Right. Okay. A is the classic. Yeah, go ahead. Mona Lisa. Yeah, the most famous painting inside. Yeah, so Mona Lisa. Okay. So it's the land of wolf. So the name actually comes from that. I am Pei, P-E-I, 贝聿铭. Do you know? 贝聿铭. Architect, he designed this pyramid. He won the contest, and he was born in Guangzhou, and was raised in Hong Kong, and came to the United States, first UPenn and then MIT.
Yeah.
Credit.
Okay. Thank you.
Yeah, want to share and talk about it?
Yeah, I have some interesting facts.
Okay, information. I only know that the highest point is about 900 feet.
Well, you know.
Look it up. Okay, very interesting.